Swayam Prabha. Digital India. Educated India.
So, here we are going to be talking about, so far what we had seen is how do we really find the probability of a word, an event, and how do you find the joint probability of two events, how do you find the conditional probability if one depends on the other, and we have also seen some examples, right. So, now we need to figure out whether what we have learned would be useful in terms of constructing a sentence, right. So, what is the normal way we construct this sentence? We can form a parse tree like what you see on the right side of the slide, where a sentence is split into a noun phrase, a verb phrase, where you will find a noun, and then in the verb phrase you will find a verb, okay, and it goes on like this. So, if you look at the cat sat on the mat, you will see the parse tree as given in the right side. Okay. So, this is based on how this sentence is syntactically constructed. Okay. So, if you know how those rules for constructing this sentence, you will be able to form a sentence. This is one way of learning the language, and that is how we have been taught when we move to the higher classes to learn some languages, right. Even though we would be able to speak the language fluently, but we are taught how to really construct the language in a grammatical fashion using those part of speech that we have learned. So, in this particular class, we will not be dealing with the linguistics elements of how you really construct the sentence. We will try to see how the sentences can be constructed using the probability and the score that we compute by looking at a very large corpus. Okay. So, as we had seen earlier in this world of building a language model, we use or assign a probability to every word sequence that is available in a document. Okay. The document contains lots of sentences, and every sentence is not restricted by the size. It could be from 5 words to 15 words, sometimes even to 20, 30 words longer, correct. So, we try to focus in terms of understanding the language sentence construction using the probability measure. Most of the computational linguistics right now focus on building the model from the huge corpus of text. So, we are going to be building application based on what we have learned. So, what are the different applications where we can utilize the knowledge that we have gained so far? One is in the speech recognition. I am now presenting the lecture and you are hearing this in English. Some of the speech recognizers that we have may not be able to decode what we have what I have spoken. Sometimes I have to said certain things in a hurry. So, let us take one small example. If I say quickly recognize speech, it could be also heard as recognize speech, right. You try to speak it little faster, recognize speech, it could be very similar to recognize speech. So, when the speech recognizer could not recognize words clearly, the NLP could come into play based on the context it had been trained on. It would be able to say that we are talking about the speech technology all over. So, we are not going to be talking about wrecking a beach, it is going to be recognizing speech or recognize speech. So, using the probability measure based on the corpus that we have been using to train the NLP system, we would be able to identify, or the machine would be able to identify that it is not the right sentence. The recognized speech is not the right sentence, but recognized speech is the right sentence, because the probability of that particular sentence is a lot higher than the second one that you find. Okay. And then using the context sensitive spelling. So, when you have written a long paragraph, right, you tend to make mistakes while typing, or some of the auto correction mechanism correct what you are typing based on certain characters that you have already typed, and you keep going because you do not want to stop your flow of thoughts. So, at the end, there will be some mistakes which the grammar, the spell checker won't have figured out because the spelling is right. So, in this case, once upon a time would be corrected as once upon a time, and there lived a king would be corrected as THERE, and then a king would be corrected as two different tokens. Okay. And then the another application would be on the machine translation. Okay. So, we want to translate from one language to the other. We have mentioned about this very briefly earlier. In order for you to really do this, you require a parallel corpus. A parallel corpus contains two corpora. One is for, let us say, English, and second one is for the other language, French in this case. Okay. So, we want to translate from one language to the other. We require some training examples. Let us use those two corpora and then try to find out what would be the right translation for each of those. Okay. So, even if the sentence is given wrongly, for example, I say artwork good, it is okay in terms when I speak, but when you write it is not the right sentence. So, the system first would use the English model and then correct that, and then probably send it to the translation engine to translate it into the other language. Okay. These otherwise could also be true. For example, if I have a model created for French, and if I made a mistake in the French sentence, that model would be able to correct that sentence and then feed it into the English translator. Okay. And then the next one would be the sentence completion. We spoke about that in the beginning of the session, where you would be able to find out what would be the next word or the sequence of words that would appear. I am sure most of you are familiar with the application Gmail. So, now there is a sentence completion available. Unfortunately, it reads your mail and tries to understand the context, and then tries to provide you certain words for you to complete, which saves you from typing those words. Okay. Other example would be OCR and handwritten recognition. Okay. There are a lot of handwritten texts that are available, and some of the OCR engines, even though they are very good with the printed words, they are only about 95 to 98% accurate, or even lower in many cases when the text is handwritten. So, in that case, when it outputs a sentence, we can run it through the model and then appropriately change the sentence right. For example, in this case, the quick brown, we do not know what the next word is, right. It is FO, it could be far, it could be fox, it could be something else, right. Also, if you look at this, the quick we can recognize as a human, but how will the machine understand, because it is a sequence, and if it does not find the dot at the top here, you can see that there are U's, right. So, the Q, if it recognizes Q properly, then it would understand that the next character could be Q, and then it could give the possible combination of the word where Q and U as the starting word, starting characters, right. So, it could be quack, it could be quick, it could be anything, right, that starts with Q and U. It could also give you Q, U, and then it, since it does not recognize the rest of the word, could say quit. It could also say queen as one of the probable word there. So, in this case, since this is quick, brown, and so on, in many cases it could recognize as quick brown fox if that particular sentence had been found several times in the corpus it had been trained on. Okay. So, these are the applications where you can apply the probabilistic language model and then use it to correct the incoming sentences based on the probability. Okay. So, I am going to be giving a very simple implementation. There could be several other modules that are part of this. I am not showcasing them. Let us assume that the model has been built and then the knowledge about the domain has been captured, knowledge about the language has been captured, the grammar knowledge has been captured, the sentence structure has been captured, and they are kept in some form for the language model to use. So, now we are inputting the input sentence. I am just using the same sentence that we had used earlier in our first slide. If the sentence is input as how or, the language model will look at the words that are incoming and then look at the corpus and then tries to figure out what could be the possible outcome for this sentence. Here I am explaining, or rather I am drawing it very clearly, that this language model would output, let us use the Ngram model of the Google. In fact, it output U as the first sentence. That means, the probability of U occurring after how or is very high. Okay. The highly likely that U could be the next word after the given how and are. So, we can see the value of that being very high there. So, now we can say that the sentence could be as the first rank, okay, and then this V as the second one, right, and then they the third one, and so on. So, this model implementation in, would have various other small modules that we are not really showing. For example, it could use a training phase, and then there is a testing involved to make sure that the model really outputs the right sentence and the words and so on. And then these are all part of the, which I am not really showing. So, I am only showing the input side of that. So, all these things are built and there is a language model available. When you feed in a new sentence, it should be able to tell you what should be the next word with the probability score attached to each of those. Okay. So, what happens, I am going to ask you a question here. So, what happens if the word that I am inputting is not part of the corpus that we have? So, this is highly likely that a new word is input and the corpus had not seen that. For example, if I say adiabatic, the language model is going to fail, right, if it had not been trained on this particular domain and if it had not had seen this, it is going to fail. So, we will talk about this, how to really take care of this situation a little later. Okay, so, now let us get on to the formal definition of how do you define a probabilistic language model. So far we have been only seeing bits and pieces of the applications of probability in terms of how do you apply conditional probability to find out whether those two words occur together or not and so on, correct. So, now we really want to compute the probability of a given sentence. As we had said earlier, the sentence is seen as a sequence of words, or you can also look at it as n-grams. Okay. The goal is to find the probability of the sequence of words. How do you do it? By predicting the next word using the probability. Given the context of the history or the history of the previous words, I should be able to estimate the next word. So, starting with the starting word. So, let us say that I am going to start with I. Okay. How many times I occurred as the starting word is what we need to find out based on the counting that we had done in the corpus, and then move on to the next word. So, after the starting symbol and the word, what could be the next word. So, in this way we can keep building our sentences together, or if the words are given, we can find out what is the likelihood of this particular sentence to occur. Okay. So, how do you do that? So, it is a very complex process in terms of the computation. If you look at it, we need to predict every word and then find out based on the previous history of that particular sentence. As I mentioned earlier, we are constructing newer and newer sentences innovatively, and then the sentence that we are forming now would not be available as part of the corpus. So, in those cases we are going to fail, right. So, it is also impossible for us to use the entire history in terms of the context in order to find the next word. So, let us move on to the definition here. A model which computes the probability for this equation using 6 is called the probabilistic model. So, a simple example would be the probability of the cat roars is less likely to happen than the cat meows, right. So, a language model is one which tries to find the or compute the probability of a sequence of words using the word probability.